So in this video we are talking about 50 questions with related answers for Apache Iceberg and related technology. So first question is, what is the difference between transformation and action in Apache Spark? Transformation are lazy operations that define new identity or data frame but don't execute immediately. Example: filter, map, select, group by. Spark build direct assembly graph of transformation. Action trigger actual computation and return result to the driver or write data. Example: select, not select, collect, count, show, write. This lazy version allows Spark to optimize entire execution plan before running anything. It can combine multiple operations, push down filter, and avoid unnecessary filter or shuffle. What is shuffle in Spark and why it is expensive? Shuffle occurs when data needs to be redistributed across partition, typically during operation like group by, join, order by, or distinct. This why it is expensive, because data must be serialized, written to disk, transfer over the network, and deserialized. It breaks the pipeline. Spark cannot execute the next stage until the shuffle is complete. Produce temporary file that consume disk import. In my work, I reduce execution time by 30% by optimizing Spark partitioning and shuffle operations. This would involve technique like reducing shuffle width using broadcast join or repartitioning data to the core located records before joining. What is difference between repartition and college? Both can change number of partitions but differ in the how they do it. Repartition always perform full shuffle. It can increase or decrease the partition, produce uneven distribution. Partition use when you need more partition or balance data. College avoid shuffle by combining existing partition on the same node. It can only reduce partition, may produce uneven distributions or may produce uneven partition but in much faster. Thumb rule is use college when shaking, means before writing to fewer output files. Use repartition when you need even distribution or are increasing partitions. Next question. You process 10 million records daily from Oracle and Salesforce. How did you tune Spark for this volume? Based on ingestion framework, I built key tuning strategies including first, partition strategy. Partitioning strategy. Partition data on high quality columns, means date region, so Spark can process partitions in parallel without data skew. JDBC parallelism. When reading from Oracle via JDBC, use partition column or lower bound, upper bound, and num partition options to read in parallel rather than single thread sequential pull. This is only where column is numeric. Command is spark.sql spark.read.jdbc in bracket URL comma table comma column is equal to id, lower bound is equal to 1, upper bound is equal to 10 lakhs, comma num partitions is equal to 100, comma partition is equal to prop. Third, broadcast join. If joining large Oracle table with small lookup table, broadcast the small table to avoid shuffle. Persist intermediate result. Cache data frame that are reused multiple times with .cache or .persist in bracket storage level .memory underscore and underscore disk. EQ, adaptive query execution. Enabled by default in 3.x, it dynamically adjusts partition count after shuffle and handles queue join partition automatically. Fifth question. Explain the Medallion architecture. How did you implement it? The Medallion architecture is the data design pattern with 3 progressive quality layers. First is raw, means bronze. Data inserted as it is from the source, no transformation, preserve original schema and format, act as an immutable loop log. In my case, data from Oracle, JDBC, and Salesforce API land here. Next layer, silver layer, means TL layer. Clean, validated, and confirmed data. Deduplication, null handling, typecasting, schema enforcement are there. This is where gold record XRF logic run, resolving identity across source. Next layer, gold layer, means AT layer. business aggregate and domain models. Join aggregates and formatted for downstream customers like analytics, dashboards, and Salesforce Sync. Key benefits: each layer is independently queryable. If downstream bug found, you can reprocess from raw without re-ingesting from the source. Next question: how does Spark Catalyst Optimizer work and how do you influence it? Catalyst Optimizer perform your logical query plan into optimal physical execution plan in 4 phases: analysis, logical optimization, physical planning, code generation. Analysis: resolve the column name type function against the catalog. Logical optimization: apply rule-based optimization, predictive push down, column tuning, constant filling, Boolean simplification. Then physical planning: generate multiple physical plans and pick the cheapest using cost-based optimizer. Code generation: generate bytecode via tungsten stage that execute as a type Java loop. How to implement it? Use data frame or SQL. Catalyst only optimize those. Collect table statistics. Analyze table T count. Question number: what is data skew and how do you handle it in the Spark? Data skew occurs when some partitions having more data significantly from the others, causing few tasks to run much longer than the rest. The struggler problem. Detection: you can use go to Spark UI if most tasks complete in 2 seconds, but if it takes 200 seconds, you have skew. Check with df.group by count order by decreasing count. Solution is sorting AQE broadcast join customer partition. Sorting: append random number to skew join key. Explore the right table n times with the all sorted values, then join on the sorted key. AQE skew join handling. Spark 3.x automatically split skew partition. Enable with spark.sql.adaptive.skew join.enable equal true. Broadcast join: if one side is small enough, broadcast it entirely to avoid shuffle. Custom partition: repartition on composite key that distributed more evenly. 8 question: what is the difference between narrow and wide transformation? Narrow transformation means each output partition depend on mostly one input partition. No shuffle required. Example: map, filter, select with column. All execute within the same stage. Broadcast join: broadcast each output partition may depend on multiple input partitions. Required shuffle. Example: group by join, order, distinct, etc. Each wide transformation create new stage boundaries. Minimum why it is matter because minimizing wide transformation is one of the primary Spark optimization strategy. In my pipeline creating work, restructuring SQL into modular PySpark pipeline would have involved identifying and reducing unnecessary wide transfer operations. Icebug: what is Icebug and why do you choose it over the transitional data lake format? Apache Icebug is an open table format for huge analytic dataset. It sits on top of the file storage S3 and LLS and provide table level and level abstraction that transitional data lake lacks. Key advantages that likely drove your pharma migration. First, asset transformation, in that save concurrent read and write without data consumption. Time travel: query on historical snapshot, select star from table name snapshot as a version of timestamp. Critical for audit level pharma. Schema evaluation: add, rename, drop column without rewriting the entire dataset. Partition evaluation: change partition strategy without migration data. Hidden partition: user do not need to know what partition layout to get partition tuning benefits. Again, hidden partitioning means user do not need to know the partition layout to get partition tuning benefits. Compared to Parquet ORC on S3, Icebug add metadata layer means snapshots, manifest lists that track exactly which data file belong to each table version. Explain Icebug snapshot model. What is manifest file and manifest list? Icebug uses 3-level metadata hierarchy. Snapshot means it represents state of the table at the point in the time. Every time instead of the delete, create new snapshot. Contain a pointer to manifest list. manifest list म्हणजे काय? अ फाईल दॅट लिस्ट ऑफ द मॅनिफेस्ट म्हणजे त्यामध्ये फाईल असते आणि त्यामध्ये फाईलमध्ये मॅनिफेस्ट लिस्टच्या मॅनिफेस्ट फाईलची लिस्ट असते विथ कंटेन partition level statistics means row count, minimum max value used for tuning without opening the manifest file. Basically, manifest list is a file that lists all manifest files belonging to the snapshot. Contain partition level statistics used for tuning without opening manifest file. Manifest files means it list the actual data files like Parquet, ORC, Avro that make up the table. Contain column level statistics for each table file. Query 4. Reader open the snapshot, read manifest list, skip the partition, then read a relevant manifest, skip the not required file using column step, and then read only the needed file data. This metadata driven approach enable O of N table operation like snapshot isolation and time travel without scanning the entire storage directory. 11 question. How does time travel work in Iceberg, and how did it help with audit log in your pharmaceutical project? Time travel in Iceberg used by querying specific historical snapshot. Every write create immutable snapshot with unique snapshot ID and timestamp. Syntax options like by timestamp, select star from table name, timestamp as of year, month, day, hour, minute, second. By snapshot ID, select star from table name, version as of snapshot ID. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 digit. In PySpark, how we can check like df is equal to spark.read dot option in bracket as dash of dash timestamp comma value, then dot table pharma dot patient. Pharmaceutical audit use case. A regulator often requires proving what data look like at specific point in time. Example, which patient record exists when clinical trial was submitted. With time travel, you can reconstruct the exact table state without maintaining separate archive table, eliminating storage duplication and risk of archiving drift. 12th question. What is compaction in Iceberg and why it is necessary? Compaction means also rewriting the files. Merge small files into the fewer large ones. Many small files converted into the large files. And in Iceberg, default size is 512 MB. This addresses the small file problem that accumulate over time from frequent streaming or microbatch write. Why it is matter? Each small file requires separate metadata entry, S3 API call or JVM over it to open. 10,000 files of A1 MB each performs worse than 100 files of 100 MB each. Iceberg compaction in Spark. From PyIceberg dot expressions import true always true. Then enter table dot rewrite underscore data underscore files bracket, and via Spark SQL call catalog dot system dot rewrite underscore data underscore files in bracket table name database name dot table name. Best practice: schedule compaction as a regular maintenance job, daily or weekly, separate from your ETL pipeline. Also run expired snapshot to clean up old snapshot metadata and remove often files to delete files no longer referred by the snapshot. How does Apache Iceberg handle schema evolution and partition evolution differently from Hive? Hive limitation. Schema changes often require rewriting the entire dataset or are simply unsupported. Partition layout is fixed, means changing it requires creating new table and merging all data. No column level tracking. Remaining column break query. Iceberg schema evolution. Each column has unique field ID. independently. Each column has unique field ID independent of its same name or position. Operations like add, rename, drop, reorder, and hidden types are tracked in the schema metadata. Existing file does not need to be rewritten. Old files are read with their schema, new file with the updates. म्हणजे काय होते जेव्हा न्यू कॉलम ॲड होते किंवा नवीन कॉलम ॲड करायचं असतो तेव्हा ज्या जुन्या फाईल्स आहेत त्या तशाच राहतात आणि नवीन फाईल्स येतात त्या नवीन पार्टिशन होतात. सपोज पहिल्यांदा केले आपण रिजनला ओल्ड फाईल्स आहे म्हणजे जुन्या फाईल तशाच राहतात. जेव्हा एक काही कॉलम ॲड करायचा असतो तेव्हा त्या कॉलम्स जुन्या टेबलसाठी डेटा असतो तोच राहतो आणि नवीन टेबलसाठी जो डेटा राहतो त्यामध्ये जो नवीन कॉलम आहे तो ॲड होतो. ओके. आइसबर्ग पार्टिशन इव्हॉल्युशन त्याला म्हणतात पार्टिशन स्कीमा इव्हॉल्युशन. आता आइसबर्ग पार्टिशन इव्हॉल्युशन म्हणजे काय? पार्टिशन स्पेस आर व्हर्जनड न्यू डेटा रिटर्न आफ्टर पार्टिशन change uses the next space. Old data retain the old space. Iceberg query plan handle both situations simultaneously during scan. No migration required. Again, partition evolution means partitions space are visionable. New data return after the partition change uses the new space. Old data retain the old space. Iceberg query plan handle both simultaneously during scan. No migration required. Example: if your pharma does it originally partition by month, but you later needed day gradually, Iceberg let you add day partition space. New ingestion use day partitioning. Historical data stay as it is. What is difference between Iceberg write mode means copy on write versus merge on read, and when would you use each? Copy on write means on every update or delete affected data files are rewritten entirely with the change appears. Reads are fast, no merging needed at read time. Write are slow and expensive for frequent small updates. Best for batch workloads with infrequent update and frequent reads. Merge on read. Update or deletes write small delta file. In bracket means delete files less position equally or equally readed. Write are fast. Only write the change records or rows. Read are slowly because we are using merge base file with delete file at query time. We are merging base file with delete file at query time. That's why it is read are slow. Best for streaming ingestion, CDC pipeline frequent upside. In my pharmaceutical migration constraint, copy on write would be appropriate for the curated layer where reads dominate. Merge on read would suit in the raw TL layer receiving frequent incremental load from Oracle JDBC. Compaction, then periodically convert merge on read files back to the clean base file. Azure Databricks. Let's go. Question 15. What is ADF and how do you differ from the Databricks? ADF is a cloud ETL orchestration service, a managed pipeline scheduler and data movement tool. It excels at scheduling and triggering workflow, time-based and event-based, copying data from multiple sources like SQL Server to ADLS, Salesforce to Block. Low code, no code, a pipeline building with 90% connectors, monitoring and alerting on pipeline runs. Azure Databricks is managed Apache platform, optimized for heavy computations, large scale transformation, ML, and streaming and complex web. How they complement each other in my architecture? ADF orchestrates the overall workflow, trigger Databricks notebooks or job at the runtime, handle data movement from the Oracle or Salesforce into ADLS. Database perform heavy transformation work, means bypass Meridian arc layer iceberg operations. ADF act as a control panel and database act as a computing engine. Means computing engine. What is Delta Lake and how does it related to Apache Iceberg? Both are open table format that add acidic transitions, schema enforcement, time travel to cloud storage. Key differences in Delta Lake created by Databricks, tightly integrated with Spark or Databricks ecosystem. Transition log store as a JSON or Parquet in the Delta Lake log dictionary. Based in class Databricks ingestion, optimized write Z ordering optimize command. Open source under Linux Foundation. Delta Lake 3.x. Then Apache Iceberg, created by Netflix, designed to be engine agnostic, means work with Spark, Flink, Twingo, Hive, Pastro. 3-level metadata, snapshot, manifest list, manifest file. In data files. Better suitable for multi-engine environment and cloud-native architectures. Open governance via Apache Software Foundation. Your choice. I used Iceberg for AWS S3 migration. This makes sense as a database. Iceberg is more portable across engine and cloud providers, while Delta Lake is optional when staying with the Databricks and Azure ecosystem. In simplification, how does Unity Catalog work with Databricks and what governance benefit does it provide? Unity Catalog is Databricks unified governance layer for all data and AI assist across Databricks workspace and cloud. Unity Catalog is Databricks unified governance layer for all data and AI assist across workspace and cloud. Three-level namespace: catalog, schema, and table. Catalog.schema.table. Example: pharmaprod.atl. pharmaprod.tl-clinical.strike milestone XRL. Key governance feature: centralized access control, means one place can manage permission across all workspace instead of per workspace Hive metastore. Column level security: mask or restrict access to specific column. Example: PII field for the user or group. Row level filters: restrict rows based on use attributes. Lineage tracking: automatic column level lineage showing data flow from source to downstream table. Audit log: who access what and when. Data discovery: search, tag, and document assets. In pharma environment with strict data governance requirements, Unity Catalogs, audit log, and column masking are essential for regulatory compliance. Question number 18. What is Azure Synapse Analytics and when would you use it over Databricks? Azure Synapse Analytics is combination of Databricks and ADF. Like it is Microsoft all-in-one analytics service combining data warehousing, big data processing, and data integration. Combining data warehousing, big data processing, and data ingestion. Core component: dedicated SQL pool, serverless SQL pool, Spark SQL, Synapse SQL, Synapse pipeline. Dedicated SQL pool means formally SQL data warehouse. Means massively parallel processing, means MPP for structured data warehousing. Serverless SQL pool: it is on-demand SQL query directly against ADLS file, means CSV and Parquet with no cluster management. Synapse Spark means managed Spark cluster similar to Databricks. Synapse pipelines means ADF-like orchestration building. When to use Synapse over Databricks? Heavy Synapse over Databricks. When to use Synapse over Databricks? Heavy SQL workload where teams are SQL native, not Python or Scala. Tight ingestion with Power BI or an Azure ecosystem. Structured data warehouse use case where with dedicated SQL pool. When licensing budget favor म्हणजे when आपल्याला एकाच ह्याच्यामध्ये सगळं पाहिजे असतं, म्हणजे Databricks-सारखं स्पार्क पाहिजे आता ADF म्हणजे पाईपलाईन कॉन्फिगरेशनसाठी, म्हणजे ADF-सारखं पाईपलाईन कॉन्फिगरेशन करायचा आणि आपला डेटासुद्धा स्टोअर करायचा. त्यासाठी आपण Synapse वापरू शकतो. म्हणजे ऑर्केस्ट्रेशन, डेटा वेअरहाऊस अँड transformation we can do in one. Next question: how would you implement CI/CD pipeline for Databricks notebook and jobs? A mature CI/CD setup for database involves several components. First, source control. All notebook and job identification in Git, Azure DevOps or GitHub. Use Databricks repo to sync. Development workflow. Developer work in feature branches, commit notebooks as source, avoid clicking and running in production workspace. Pipeline stages. PR means pull request. Run unit test in bracket test plus pipa for PySpark. Then merge. Deploy to dev workspace to deploy to dev branch via Databricks CLI or Terraform. Then QA approval. Deploy to staging from dev. Then manual gate. Deploy to production from QA. Where. Then fourth, deployment tool. Databricks CLI, Databricks Terraform provider, DBDX. Database CLI means Database job create or update or Database workspace input. Database Terraform providers. Infrastructure as a support for cluster job permission secret. DBX means Database deployment tool that manage job configuration as a YAML. Testing use Kipa for Database equality acceleration. Mock external data source. Run against small fixed Databricks dataset in CI. First version. Let's go to one by one. First version notebooks in Git store all notebook and job. फर्स्ट काय होते पहिल्यांदा काय करायचं वर्जन करून करायचं वर्जन नोटबुक इन गेट स्टोर ऑल नोटबुक अँड जॉब आयडेंटिफिकेशन इन गेटअप और Azure DevOps sync with database repo. Develop in feature branch, work in isolate branch and commit changes. Avoid editing directly in the production workspace. Run CI continuous integration unit test on pull request. Run PyTest and Skipa test against fixed dataset to validate logic. Deploy to dev environment after merge. Use Database CLI, Terraform or DBX. Deploy notebooks and job to the dev environment. Then promote to staging with QA approval. Deploy to staging for integration, testing and validation. Get promotion release. Use manual approval before deploying to production. Ensure jobs cluster and secrets are correctly configured. Next question is what is Delta Lake and how does it differ from Delta Warehouse and Delta Lake? Delta Lake means raw file stage S3 and LLS with no schema enforcement. Cheap storage, flexible but no acidic, no performance aggregation, no time travel. Schema on read can be inconsistent. Data warehouse structure, it is structured as schema on write, highly optimized for SQL queries, Snowflake, Redshift, BigQuery, but expensive. Regard schema cannot handle unstructured data warehouse. Combine both mean data lake and data warehouse. Source files cheaper by object storage like lake, but adds the table format layer. Iceberg Delta Hoodie that provide acidic transition, schema enforcement and evaluation, query performance mean metadata based querying, support for multiple query engines. My architecture is Delta Lake. Raw files on S3 plus Apache Iceberg table format plus Spark Compute, giving you warehouse quality, reliability at scale, lakehouse economics. Then what is JDBC and how would you use it to ingest from Oracle? JDBC is stored means Java database connectivity as a standard Java API to connect to the relational database. Spark includes JDBC connector that let you read or write from any JDBC compatible database. Syntax is dev is equal to spark.read option bracket URL, JDBC URL, then option username, password, then DB table, database name table name, then driver, value to the driver oracle.use.driver.oracle driver slash fetch size in bracket 5000 option bracket fetch comma size 5000 means at each run it will take 5000 records per API call. Then load. Explain how do you achieve 99.9% data uptime in your ingestion pipelines. So achieving 99.9% uptime means less than 9 hours of downtime per year. In data pipeline constraint, this involves multiple reliability layers. First, add-on to test
running the operation multiple times will yield the same result as if it was executed only once. According to Block, Dream Factory, idempotency is a property of certain
idempotency ingestion. Each pipeline run produces the same result whether run once or multiple times. Use iceberg merge into or delta merge to assert rather than build append. So rerun does not duplicate record. Checkpointing. For streaming or incremental load, track watermark means last processing timestamp or ID in control table, or on failure resume from last checkpoint rather than reprocessing everything. Retry logic with backup. Salesforce API call may transiently fail. Implement exponential backup with the same maximum retry count. Dead letter queries. Malform records that fail validation are routed to the quarantine table rather than failing the entire pipeline. Monitoring and alerting. ADF pipeline failure alerts, driving job notification email, and data quality acceleration that trigger alert when raw count additive significantly from baseline. What is incremental loading and how do you implement in the Spark? Incremental loading, like we are using watermarks approach. Like incremental loading processes only new or changed data since the last run rather than the reloading the entire dataset each time. Track the last maximum timestamp of the last processing record. Select df.spark.read spark.sql in bracket select maximum produced at from table name where table is equal to patient in bracket complete dot collect bracket complete 0 0 1 means we are taking the only first value and into the value.
ज़्यादा हिट है